Right now, across the US, we're witnessing one of the most aggressive and rapid technological shifts in modern history. I mean, literally every company, from a Fortune 500 tech giant to the mid-sized logistics firm down your street, is drowning in information. They've got terabytes of customer behavior, operational metrics, and market trends, but they have absolutely no idea what to do with it. That massive gap between just collecting information and actually understanding it, well, that's created a total gold rush. So we're mapping out the data science roadmap for 2026, and in today's explainer, we're looking directly at the landscape. We're going to strip away the hype, ignore the buzzwords, and focus exclusively on the reality of the US job market. If you're a focused learner trying to figure out exactly how to navigate this industry, you absolutely need to understand the board before making your first move.
34%. Now, this isn't some arbitrary prediction from a random tech blog. This is the official projection from the U.S. Bureau of Labor Statistics for data science job growth between the years 2024 and 2034. To put that into perspective for you, the average growth rate for all other occupations hovers somewhere around just 3 to 4%. So we're talking about a field expanding nearly 10 times faster than the national average. A 34% projected job growth means hundreds of thousands of new seats are opening up at the table over the next decade. Companies aren't just hiring to replace people who left, they're actively inventing brand new departments, expanding their analytics capabilities, and desperately searching for literally anyone who can make sense of their digital footprint.
And because that demand is so radically outpacing the supply of qualified talent, we get this number. $112,590. That is the median salary for a data scientist in the United States right now. And notice I said median, meaning half of the people in this field are actually making even more than that figure. When an industry goes through a 34% growth rate, the compensation naturally skyrockets to attract top-tier problem solvers. This specific career roadmap represents a highly lucrative opportunity in the US market. But here's the catch. It only pays off if you actually understand what you're getting hired to do.
Section 1. Defining true data science. Okay, let's dive into this.
Because if you go out and ask 10 different recruiters what data science actually is, you'll probably get 10 completely different answers. The financial opportunity is clearly there, for sure. But to capture it, we've got to clear up all this prevalent industry confusion. We have to separate the actual science of data from the countless other IT and engineering roles that just kind of get lumped into the same bucket. So let's clear it up. True data science is the intersection of three specific pillars: statistics, programming, and domain expertise. Think of it like a three-legged stool. You need the statistics to ensure your findings are mathematically valid, right? Not just random noise. You need the programming skills, usually stuff like Python or R, to actually manipulate massive data sets that are way too big for a standard spreadsheet. And crucially, you need domain expertise. You really have to understand the specific business or industry you're operating in. When you combine those three elements, your ultimate goal is to extract actionable insights. You're not just reporting on historical numbers or saying, hey, here's what happened yesterday. No, you're using mathematical rigor and code to uncover hidden patterns and tell the business exactly what they should do tomorrow.
And this brilliantly illustrates the exact boundaries of the profession. The fog instantly lifts when we compare them side by side. Data analytics, that's fundamentally about reporting the numbers. It's looking in the rearview mirror to track KPIs and summarize past performance. Software engineering, on the other hand, is entirely focused on building systems. They create the applications, the platforms, the architecture that keep a company running. But data science sits right in its own unique lane, extracting insights. It leverages the historical reporting of analytics and the programmatic tools of software engineering to actually predict future outcomes and drive those high-level strategic decisions.
But hold on, stop for a second. We've looked at the massive 34% growth, the six-figure median salary, and the high-level definition of the field. But a massive industry projection doesn't just hand you a paycheck, right? And a broad definition doesn't give you a daily task list. So the absolute most important question you need to ask yourself right now is, where do you actually fit in? Because the title data scientist isn't just one job anymore. It's totally fractured into an entire ecosystem of highly specialized careers.
Section 2. 7 in-demand roles. Let's break down this ecosystem.
Look, if you're going to invest your time in learning these skills, you need to target a specific trajectory from day one. Let's break down the frontline roles first, just so you know exactly which path aligns with your strengths. First up, the data analyst. That's your foundation. They're the ones who query the databases and report the numbers to answer direct business questions. Moving a step further, as we established, the data scientist uses statistics to extract deep, predictive insights. Then we get into the highly specialized engineering side with the machine learning engineer. Their entire job is to take that predictive math and actually build scalable, automated models that can learn from new data. And finally, the AI engineer. They focus on integrating intelligent systems, think large language models and neural networks, directly into consumer-facing applications. Every single one of these 4 paths requires a totally different balance of statistics versus programming.
But here's the thing, none of those frontline roles can function without critical back-end and deployment infrastructure. Data doesn't just magically appear ready to be analyzed out of thin air. And that brings us to the data engineer, the person who physically builds the infrastructure and pipelines that securely transport data from the source to the servers. Next is the BI developer, or business intelligence developer. They take all that complex data and create the interactive, automated dashboards that non-technical executives actually use on a daily basis. And lastly, the MLOps engineer. They act as the bridge between data science and software operations, making sure that those complex machine learning models can be reliably deployed, monitored, and maintained in a live production environment. Honestly, these 3 roles are the unsung heroes holding the entire 2026 data landscape together.
So, you now know the stakes, the definitions, and the 7 distinct roles that are driving that incredible 34% job growth. But knowing the destination is completely useless if you take the wrong first step. You have to ask yourself, are you just chasing shiny AI buzzwords? Or are you actually prepared to build the mathematical foundation required to survive in this industry? Because the biggest mistake people make? Skipping the hard stuff. In part 2 of this explainer, we're covering the exact skill order you need, starting with the math and programming reality check that most beginners completely ignore. See you there.
Okay, let's dive right into this. Welcome back, everyone here in the US, to part 2 of our explainer breaking down the data science roadmap for 2026. Today is incredibly exciting because we are finally moving way past the theory. We're putting together a highly actionable, step-by-step blueprint for your career. We're going to outline the exact foundational skills you need and literally the exact order you need to learn them to crush it in the modern tech landscape. But hey, real quick, just to ground us before we start building, remember in part 1 of this explainer, we completely mapped out the broader industry landscape and pinpointed those 7 distinct roles that make up the modern data ecosystem. That was our lay of the land, right? Just giving you that crucial context for exactly where you might want to fit in. All right, let's move right into section 1, the foundational skill stack. This is all about pouring the concrete. Now, what's really interesting here is how the source completely strips away all that crazy industry hype to reveal what actually matters first. Think of your career architecture exactly like building a house. Before we can even think about putting up the walls, adding some fancy windows, or, slapping on a shiny new roof, we absolutely must pour a solid, immovable concrete foundation. According to the data, these are the core, non-negotiable, sequential base skills you absolutely have to have before you should even attempt to touch advanced artificial intelligence. It's the absolute bedrock of your technical ability. And here is the exact chronological order you need to follow to build that bedrock. Seriously, don't mix these up. Step 1 is math and statistics basics. You simply have to know what's happening mathematically under the hood of these systems. Step 2 is Python. It has just emerged as the undeniable, absolute language of modern data work. And step 3 is SQL, which is basically the essential tool for querying and managing the lifeblood of your work, the data itself. The sources we're working from firmly emphasize this. Mastering these 3 skills sequentially, math, then Python, then SQL, is completely non-negotiable. Which brings us to a very serious point. A warning, actually. Do not skip the basics. Look, I totally get it. Being told to focus on math and SQL is kind of like being told to eat your vegetables. It isn't always glamorous, is it? It's incredibly tempting to read these massive, exciting headlines about AI and just want to jump right into the deep end of the pool. But in this explainer, I've got to give it to you straight. You absolutely must trust the blueprint here. To really drive this home, check out this powerful insight derived straight from the source material. Jumping to deep learning before mastering the fundamentals is a fatal career error. We really need to emphasize the why behind the super strict rule. Look, skipping straight to the sexy, highly publicized deep learning stuff without having that bedrock of math, Python, and SQL, it means you won't actually understand what your models are doing. And believe me, when a model breaks, or hallucinates, or just flat out fails to deploy, and trust me, it will, you won't have the underlying knowledge to fix it. It's pretty much a guaranteed path to failure. Okay, so let's move forward and see how this builds in Section 2, Advanced Machine Learning and AI. It's time to start framing the house. Now that our concrete foundation is totally cured and rock solid, we can shift our momentum forward. Once your basics are locked in, you move to Step 1, Classical Machine Learning. Understanding how standard traditional algorithms actually learn from data naturally paves the way for Step 2, which is large language models and RAG. That stands for Retrieval Augmented Generation, by the way. You're building on classical ML to understand these modern text-based powerhouses. And ultimately, that knowledge flows directly into step 3, MLOps. This is the absolutely crucial final stage, where you learn how to actually deploy, monitor, and maintain these complex models out in live production environments. And this brilliantly illustrates why honoring this strict order creates highly capable tech professionals who are completely ready for the 2026 job market. If you take the skipping fundamentals route, well, you end up with a pretty frail foundation. You might know a few impressive buzzwords to throw around at parties, but you're going to suffer from a complete inability to actually deploy a working system. On the flip side, the sequential stacking route yields a totally robust, resilient skill set. You actually understand the whole pipeline, which leaves you fully ready for modern MLOps and real-world problem solving. Moving right along to Section 3, the Advanced Degree Dilemma. Let's talk about HR filtering. We really have to address the elephant in the room here. Because let's be totally honest, all the perfectly stacked skills in the world feel pretty useless if you can't even get your resume past the initial HR filter. The gatekeeping in the US hiring market is real, folks, and it can feel incredibly daunting when you start scrolling through those job boards. The traditional requirements listed on these applications, they can easily make you feel like you need a lifetime of wildly expensive academia just to get an entry-level interview. But stop right there for a second. 60%. Roughly 60% of job postings in this field list a master's degree or a PhD as preferred. Let that heavy statistic sink in for just a second. More than half of the jobs you're looking at in the US market are explicitly telling you that they'd really prefer someone with an advanced academic pedigree. It's an intimidating, overwhelming reality, and it stops a lot of incredibly talented, self-taught people right in their tracks before they even hit apply. So the crucial point is, how do we get around this? Enter Section 4, the Portfolio First solution. This is how we bypass those gates. You absolutely do not have to let that 60% metric defeat you. According to the roadmap, there is a highly actionable, incredibly empowering workaround to this specific degree problem. And the best part? It's something you have complete control over. If we weigh these two paths against each other, on one side, we've got the traditional master's or PhD preferred route. We all know it, it's time-consuming, it is wildly expensive, and it is heavily theoretical. But on the exact opposite side, we have the portfolio first approach. This is the modern, practical alternative that forward-thinking hiring managers are actively looking for right now to bypass that traditional credentialing. Now, the exact requirements of this portfolio solution are pretty strict because you really have to get this right. The sources note that you need 3 to 4 projects, but listen closely to this part. These cannot just be simple, half-finished scripts sitting on your laptop. No way. They require end-to-end execution. They must be fully deployed so a hiring manager can actually click a link and interact with them. This specific combination is exactly what proves real-world capability. The data shows that having 3 to 4 end-to-end, fully deployed projects in your portfolio can completely compensate for lacking a formal advanced degree. Just to reiterate the reality of the 2026 landscape, practical application is so much greater than traditional credentials. Proving that you can actually build, troubleshoot, and deploy real systems completely beats theoretical knowledge on a piece of paper. Companies want builders, right? They want people who can drive business value immediately. A deployed portfolio proves that you are a builder who truly understands the entire life cycle of a project. Which naturally leaves us with one massive, provocative question. So what exact projects will get you hired in 12 months? We know you need 3 to 4 of them, but what specifically should they be to guarantee you actually stand out from the crowd? Well, that is exactly what we're exploring next. In part 3 of this explainer, we're going to break down the realistic 12-month timeline and reveal the specific portfolio projects that actually win job offers. You absolutely won't want to miss it.